Okay, let's continue. Um, we have lambda scopes. Lambda scopes. Accessing outer scope variables from lambda expression is very similar to anonymous object. You can access finite variables from the local outer scope as well as the instance fields and static variables. Okay, you can access final variables from the local outer scope, as well instances of field and static variables. Instance fields, static variables. Okay. Accessing local variables. We can read final local variables from the outer scope of lambda expressions. So this is the first example with lambda. Lambda scopes. Okay, so in this case you will have a final okay. We're going to still use the converter. Wait. Okay, in this case, the lambda is from a value from and the function will return the string value of from plus num. Okay. Okay, so in this case I have a I have created a lambda. This is in the same scope. The lambda is in the same scope than the final number, and it can access the final integer. Okay. Okay, so but different to anonymous objects, the variable num does not have to be declared final. This code is also valid. This is, I think this is because it's in the same scope. So anonymous objects. Okay. However, num must be implicitly final for the code to compile. The following code does not compile. Writing to num from within the lambda expression is also prohibited. Yeah, so if I change this, the compiler shall fail. That's what it says. Oh, it makes sense. So here it's throwing me an error. Oh, it makes sense. So if I... It sort of like infers that it's final, that I'm not changing its value, but if I change its value... Oh. The other thing was if I do this, but I change same here. Okay, that makes sense. Accessing fields and static variables. In contrast to local variables, we have both read and write access to instances, fields, and static variables from within the lambda expression. Oh. This behavior is well known from anonymous objects. Okay, so in this case, I want to access fields or static variables. Okay. Okay, so in this case I will have converter from integer to string. Okay, in this case I will change the outer num equal 23. Some number, and I will return Yeah, so in this case, what's happening? Oh yeah. So in this case, I will have an instance of this lambda 4 within the. I have a lambda, and it can access an instance. It's not a local variable. This is a field from this instance, because this is the same to say this, that, outer none. Okay, makes sense, and I can change it. Okay, let's see what about static. Okay, so in this case, it's entering to an static field and it's changing its value. Yeah, it makes sense, because statically means that it will be instantiated. You don't need to instantiate it in order to use it. So, okay. Accessing default interface. Remember the formula example from the first section. In interface, formula defines a default method sqrt, which can be accessed from each formula instance, including an anonymous object. This does not work with lambda expressions. Default methods cannot be accessed from within lambda expression. The following code does not compile. Default methods cannot be accessed from the lambda expression. Let's see. Okay. Building functional interfaces. The JDK 1.8 API contains many building functional interfaces. Some of them are well known from older versions of Java like Comparator or Runnable. Those existing interfaces are extended to enable Lambda support via functional interface annotation. But the Java 8 API is also full of new functional interfaces to make your life easier. Some of those new interfaces are well known from the Google Guava library. Even if you are familiar with this library, you should keep a close eye on how those interfaces are extended by some useful method extension. Oh. Okay. Predicates. Predicates are Boolean valued function of one argument. The interface contains various default methods for composing predicates to complex logical terms and or negate. Also, this is an interface. And I'm adding an implementation with a Lambda. So in this case, okay, let's try with this. That's it. Oh, there it is. Predicate of what type? String. This is okay, this should be Boolean, that's why it says if length is greater than 0. What is happening? Predicate cannot be resolved to a type. So according to this should work, but here the compiler does not understand the function. It's not, because it's not expecting. Yeah, it's not expecting. That's interesting. Let's see. So here it's trying to create a predicate that does not work right now. It's using the predicate, so the predicate's an interface that have test. Because it's a set in the string. Also, it has another method that it's negate. Oh, but we can test that. Yes, additionally, I cannot test this, but perhaps this will work. So let's see. What about predicate boolean unknown? Predicate boolean. So in this case, string is hello objects, normal objects, normal. the same problem. Okay, somehow I cannot compile predicates with lambda expressions. Let's see. But yeah, this is interesting. Functions. Functions accept one argument and produce a result. The default methods can be used to chain multiple functions together, compose, and chain multiple methods. That's interesting. It makes sense in functional programming. So in this case, we're creating a function. So it seems that always it accepts to maybe the input and the output, as always. So let's try this. Okay. Method reference not expected here. Oh, weird. Because Oh, that's interesting. Perhaps the predicate was a similar problem. So, although I have imported the UTM rasteries, it did not resolve. There may be multiple implementations within UTMs. So that's why. Okay. So before going to, I want to test predicates before this. So maybe a similar problem. So let's say, so for predicates, we say that we will create a predicate that accepts one parameter, that's a string, or we can call it predicate. And this will be a lambda function that accepts a string, and it will return whether the string is greater than the length of the string is greater than 0. Here we had the same problem, but it was due to oh yeah, the problem is that it has multiple implementation. Okay, now it compiles. Yeah, perfect. Yeah, that was the problem. Yeah, so what we want to do is that is the value of predicate test for a string whatever. see. It compiles and we run it, it says true. And the next one we want to negate. So we have the same, but want to negate. This is a function. Method. Okay. Okay, this is good, this is good. So that means I can create predicates. So in this case it will accept a boolean and it will check whether it's known or non-known. Okay, oh, interesting. I can even reuse. I can even reuse this the negate function. Oh, that's good. That's good. Okay, now I think we can go. Okay, now I. Yeah. Okay, I don't need the predicates anymore. I will need its function, and what we were testing is to get the integer value. It will be string. And this is not working because it requires an import. Okay, back to a string. Because we want to test the chain, so it's creating another function that in this case it will accept an integer. I will output a string. In this case, I think we're using string. Oh no! Yeah. Let's see what's using. This in two integer. And then we can send string value of wait, what's happening here? Why it's let's see. Oh, my bad. Yeah, it makes sense because the input will be still the string, but this will output an integer, but it's in the middle, and the output will be still in a string. Yeah. Okay. Then yeah, I can test this. So in this case, I will call back the string. Now we send the example. Am I wrong? Oh, it needs to call and apply. It's not like you can call it directly. You need to call apply. Okay, that will execute the... Yeah, well, it makes sense. So makes sense. Okay, then we have suppliers, consumers, comparators. I think we will stop here with predicates and functions.